Hi guys, so in this episode we are going to be learning about two-step equations. So this topic we discussed in class on Monday and Tuesday, but I wanted to make sure that we had some good commentary and examples to use to make sure that we understand two-step equations so that we can move on to multi-step equations. This is going to match up with lesson 3.1, so chapter 3, lesson 1. So in this episode we are going to learn and review how to isolate a variable in a two-step equation. It's going to be very similar to isolating a variable in a single-step equation. We're going to learn how to keep an equation balanced in a two-step equation. So what we do to one side, we have to do the exact same thing to the other side. And then we're going to learn how to solve a two-step equation. So the first equation that we're going to start with is 7x plus 12 equals 26. And our goal is to isolate the variable, meaning I want to get x by itself. So right now, if we look at what's happening to x, it's next to a 7, which means it's being multiplied by 7, and there is a plus 12. So the operations that are happening to x right now are addition and multiplication. So if we want to undo our addition and multiplication to isolate our variable, we need our inverse operations. So the inverse of multiplying is dividing. The inverse of adding 12 will be subtracting 12. So then we need to decide what to get rid of first. Do we want to get rid of our plus 12 first or our times 7 first? And to show you that, I'm going to move over to my drawing feature. And so again, the equation that we're working on is 7x plus 12 equals 26. And so if I want to get x by itself, so my goal is to isolate my variable, I want it to look like a single-step equation. Right now it's a two-step equation. And so I'm going to take away 12 from both sides of my equation. The reason why I chose to take away 12 is because when I have a plus 12 and a minus 12, that's going to cancel out and make 0. So this cancels out, but to keep my equation balanced, this side will weigh less. So I need to come over here and make this side weigh less, which means I'm going to subtract 12. 26 minus 12 is 14. So now I want to rewrite what my new equation is. So on the left, I just have 7x, and on the right, I have 14. So now I have 7x equals 14. This should be the kind of equation we can do in our head. So 7 times what gives me 14? That would give me 2. So I would write x equals 2. Now if I wanted to show my work of what I did to isolate my variable, I think I am multiplying by 7. The opposite of multiplying by 7 is dividing by 7. 7 divided by 7 will give me 1. 14 divided by 7 will give me a 2. So this will become 1x equals 2, or x equals 2. Now, the reason why we can't divide by 7 first is this kind of relates to our distributive property. And so if I divide by 12, I have to put this, if I divide by 7, I have to put this in parentheses, just like I would do if I was doing the distributive property with multiplication. So if I wanted to divide 7x plus 12 by 7, 7x divided by 7, that's easy, that's 1x. But 12 divided by 7, or 12 over 7, is not going to be friendly. So then I would have this equal to 26. I don't really want to be working with a fraction. So I don't want to divide by 7 first, because I have to divide both by 7. It's just like if I was multiplying this side by 7, I would need to use my distributive property to distribute the 7 to both. It's the same thing with division. So we want to do our subtracting or getting rid of our 12 first. So that answer will be x equals 2. So moving on to our next equation, we have x over 12 plus 13 equals 18. So when I think about my goal is to isolate my variable or get x by itself, so how am I going to do that? Well, I'm going to look at what operations are happening to x. Right now it's being divided by 12, and then I'm adding 13 to it. So in your mind, I want you to think, which do I want to get rid of first? My adding 13 or my dividing by 12? Well, the first thing that we're going to want to get rid of is our adding 13. So then I think, how do I get rid of my adding 13? So my goal is to get this to go away, aka to make it 0. So how am I going to make that go away? Well, since I have a plus or an addition of 13, the opposite or the inverse of adding 13 is subtracting 13. So 13 minus 13 will make 0. This has now canceled out, but now I need to balance my equation, meaning I need to subtract 13 from the other side. So notice I'm doing the same thing to both sides. So 18 minus 13 will give me 5. So now my equation is x over 12 equals 5. So now this is a single step equation. So I look at what operation is happening to x. Some of y'all like writing it like this. I am dividing by 12. So if I want to get rid of my dividing by 12, I need to do the inverse of division, which is multiplication. And I'm going to be multiplying by 12. Because if I think about it this way, x over 12 times 12, or times 12 over 1, when I'm multiplying fractions, I multiply my numerators, so x times 12 over 12 times 1, which is going to be the same as 12x over 12. So I think about what 12 over 12 equals. Well, 12 over 12, or 12 divided by 12, will be 1, so this will make 1x. So when I multiply by 12 over here, this is going to cancel out, but now I need to multiply by 12 on the other side. So 5 times 12, I can come over here and do my work, or you can do it mentally, will give us 60. So x equals 60. So if I want to make sure that my x equals 60 is correct, I'm going to plug it in wherever I see an x. So I'm going to do 60 over 12 plus 13 and make sure that equals 18. So 60 divided by 12, 12 is going to go into 65 times. So 5 plus 13 equals 18, which is what I wanted. So that means that x equals 60 is correct. Okay, the last one that we are going to do is 250 equals 124 minus 3x. So this one's going to look a little bit different because what's happening to our variable x is we are multiplying by 3, and then we have this subtraction here. So if we look at this expression over on this side, 124 minus 3x, my goal is to get x by itself. So I need to get rid of this 124, this minus, and this 3. So if I choose what I want to get rid of first, I choose either to get rid of my 124 or my minus 3. So what do you think we're going to need to get rid of first? Well, we're going to want to get rid of our 124 first. So 124, though, does not have a symbol in front of it, right? So when it doesn't have a symbol in front of it, I'm going to assume that that's addition, or it's a positive 124. So if I want to get rid of a positive 124, I'm going to subtract 124. 124 minus 124 makes 0, so this canceled out. Then I need to come over to the left and do the same thing. So now I'm going to subtract 250 minus 124, and I will get 126. So now my equation is 126 equals a minus 3x, so I need to keep that minus in front. So now I have a single step equation. So now I need to get rid of my minus 3. So now I need to think what operation is happening between my minus 3 and my x. I'm multiplying. So since I'm multiplying negative 3 times x, the opposite of multiplying is going to be dividing. So what I'm going to divide by is my negative 3, because negative 3 divided by negative 3 equals 1. If I chose a positive 3, a negative 3 divided by 3 would be a negative 1. We don't want a negative 1, we want a 1. Some of y'all have gotten a little bit confused and you see a minus, so you think, ooh, to get rid of this minus 3, I'm going to add 3. But addition is not the opposite of multiplication. If I add 3, so if I do negative 3x plus 3, those are unlike terms, so I can't combine those. So that's not going to be helpful. So I'm dividing this side by negative 3, so I need to come over and divide this side by negative 3, and I will get negative 42. So my answer is negative 42 equals x. Thank y'all so much for watching this episode. I hope that it helped. Hope that it becomes a little bit clearer, and then we will spend time in class on Wednesday going over a little bit more. Have a great rest of your day.